Come revise A-level chemistry with me. What are the strongest weak intermolecular forces in these molecules and where do they come from? Methane only has van der Waals forces, the weakest type of weak intermolecular force. These arise when the random movement of electrons leads there to be slightly more electrons on one side of the molecule than the other. This creates a temporary dipole. And in the brief instance where that side of the methane molecule is slightly negative because of the extra electrons, it's repelling the electrons from the adjacent methane molecule, which creates a temporary positive dipole on that side. And then those temporary positive and negative dipoles are attracted to each other. Chloromethane experiences permanent dipole forces. This is because of the difference in electronegativity between the central carbon atom and the chlorine atom. This leads to a polar covalent bond, where the carbon is slightly positive and the chlorine is slightly negative. The attraction between the slightly negative chlorine on one chloromethane molecule and the slightly positive side of the other chloromethane molecule leads to this permanent dipole force, which is stronger than a van der Waals force. Now, tetrachloromethane, the strongest force is van der Waals forces. But you just said the carbon-chlorine bond was polar. It is, but in tetrachloromethane you have 4 bonds that are all polar in the same way, and it's a symmetrical molecule. So they're kind of balancing each other out, and the molecule as a whole doesn't have one positive side and one negative side. It just kind of has like a negative outside and a positive inside, which is not super useful for 2 molecules attracting each other. Hydrogen fluoride is a classic example of a molecule with hydrogen bonding, because we have a huge difference in electronegativity between the hydrogen at one end of the molecule and the fluorine at the other, which creates an incredibly polar bond. And then fluoromethane, we're back to permanent dipole. But you just said there was a massive difference in electronegativity between hydrogen and fluorine. Yep, but they're not bonded to each other in fluoromethane. The central carbon atom is making 3 bonds to hydrogen and 1 bond to fluorine. So even though the carbon-fluorine bond is very polar, there isn't a bond between fluorine and hydrogen directly.